Hi everyone, today, I'm going to demonstrate 4 parallel migrations using QMigrator, Oracle to Fabric Open Mirroring, MySQL to Fabric Open Mirroring, Postgres to Fabric Open Mirroring, and Oracle to Databricks. These migrations, along with CDC, are executed autonomously through QMigrator's job agent, which handles back-end operations and automatically triggers CDC. I have already configured source connections like Oracle, SQL Server, and Postgres. Similarly, and target connections are Fabric Lakehouse, Fabric Open Mirroring, Fabric SQL Server, Fabric Data Warehouse, and Databricks. For this demo, we are focusing on migrations to Fabric Open Mirroring and Databricks. The Oracle database includes an employee_details table with around 100,000 records, MySQL has 22,000 records, and Postgres has 142,000 records. Using the QMigrator configuration screen, I selected E2E data load to perform both initial load and CDC, and used pre-created configuration files. Now, coming to the job agent, this is where the actual data migration begins. We need to select the source connection, the target connection, and then start the agent. In this case, I will initiate the migration for all 4 source target pairs. Once jobs were triggered via the job agent, the scheduler confirmed that all CDC tasks were running. We verified load counts: Oracle 104,000, MySQL 22,448, Postgres EMP 142,004, and Databricks 104,000, confirming successful migrations. Now, proceeding with the transaction operations, starting with Oracle, then moving to MySQL. Once those are completed, I execute the Postgres run functions, which also finish successfully. Returning to QMigrator, all 4 migration jobs are actively running. When I select any of them, we can view detailed logs showing that the changes are being captured and written to the target database, specifically the Fabric Mirror database. The record count is visibly increasing in real time. For instance, the logs indicate that approximately 107,000 records have been added. Checking the EMP data, we see an increase of around 2,000 records, confirming that the CDC process has been successfully completed. Now, checking the Databricks target, we can see that 2,000 records have been added, increasing the count from 104,000 to 106,000. This confirms that the Databricks CDC process is also complete. This demonstrates how the entire migration and CDC process is running seamlessly and autonomously. This is the data migration dashboard for the Oracle database to Fabric Open Mirroring data migration. Starting with the data migration snapshot. The source data size was approximately 943.40 gigabytes, which was compressed to 159.8 gigabytes on the target side. This reduction is due to the fact that the data is not stored as a traditional database but rather as Parquet files in the target, enabling efficient storage. The total row count on both source and target was 448.7 million, spread across 74 tables. Moving on to migration performance stats. CPU and memory utilization. The system used an 8-core CPU and 32 gigabytes of memory. On the source side, CPU usage peaked at 20%, and memory usage reached 58.5%, indicating efficient resource utilization. Regarding throughput, the maximum recorded data transfer rate was 29 megabytes per second, with a minimum of 11.36 megabytes per second and an average of 19.9 megabytes per second. In terms of max RPS is 26,148 records per second, the minimum was 13,890 and the average was 19,146 records per second. Next, coming to validation stats, all 74 tables and the 448.7 million records were validated both during and after the initial load. The initial validation checks each table individually, while a post-migration validation performs a full schema-wise database comparison to confirm complete and accurate migration. Regarding CDC, a total of 3.8 million batches were extracted and loaded. These batches included 14 million transactions, comprising inserts, updates, and deletes, amounting to 4.2 gigabytes in total data size. The CDC throughput was 9,980 records per second. Maximum data throughput during CDC was recorded at 1.8 megabytes per second, with a minimum of 1.38 megabytes per second. The lag in extraction was around 1.2 minutes, and the loading lag was approximately 1.4 minutes, demonstrating near real-time performance. In addition to the dashboard, there is a detailed blog available on Oracle to Fabric migration. This blog covers the overall architecture, explaining what QMigrator is, why Microsoft Fabric is a preferred choice, and the key benefits it offers over other tools. It highlights QMigrator's advantages, such as a scalable Kubernetes-based architecture and an autonomous job agent. The blog also includes the integration architecture, showing all supported sources and targets such as Fabric and Databricks. It outlines the ETL architecture and walks through the prerequisites for data migration, such as database credentials, valid logins, and licensing requirements. Detailed screenshots guide the user through steps like application registration and Fabric authentication setup, which uses a client secret instead of user credentials. The blog further explains how to generate necessary access permissions via the Azure portal. It also covers how to configure QMigrator, setting up source and target connections, creating configuration files, understanding the E2E migration flow, and interpreting each configuration setting. It walks through initiating the job agent by selecting source and target connections, after which QMigrator autonomously handles conversion, data migration, and CDC. A scheduler screen is available where users can track logs, monitor task completion, and identify any errors. For data verification, users can directly access the Fabric environment to ensure that the data has been migrated correctly and conforms to the required structure. Thank you.